powerful and deadly. I'm talking about antimatter, the most valuable substance in the world. A thimble of antimatter would be enough to blow up an entire city. In one of my videos, I already detonated an antimatter bomb on Earth, but that's not enough for me. Today, I want to detonate an antimatter bomb in space and see what happens. Will the Earth and other planets withstand such a blow? Today, a very risky experiment awaits us. You'll learn why it's so much more dangerous to detonate antimatter bombs in space than on Earth. I'm going to tell you about a secret space test created by people and even bigger explosions created by the universe. Get ready. A giant information bomb is about to go off. So, what is antimatter? It's all quite simple and complicated at the same time. It's a substance consisting of antiparticles. These have an opposite electric charge from their corresponding common particles. The nuclei of their atoms consist of antiprotons and antineutrons, and their shells of positrons. In nature, antiparticles occur inside massive stars, near pulsars, in active galactic nuclei, and when cosmic rays collide with the Earth's atmosphere. There are other sources of antimatter, ones that are much closer to people. You'd be surprised, but bananas also produce antimatter. However, not much, just one positron. They can produce about one every 75 minutes, but the fact itself is striking. This is because bananas, like our body, contain a small amount of potassium-40. When a potassium isotope decays, a positron is born. As for scientists, they use colliders to produce antimatter. Antiparticles in a stable state have not yet been found in nature. The problem is that when a particle meets its counterpart, it produces a violent reaction. Mutual destruction occurs and a huge amount of energy is released along with it. I'm not exaggerating about the power of antimatter. See for yourself, if you took 1 kilogram, about 2 pounds of antimatter, and the same amount of matter and combined them, you'd release as much energy as burning 30 million barrels of oil. I know, it's difficult to imagine such a number, so I'll give you an example. 1 barrel of oil produces enough gasoline to travel 1,685 kilometers, or 1,047 miles. With 30 million barrels, you could travel around the world more than 1 million times. But if this same amount of antimatter exploded, the consequences would be disastrous. The affected area would be 7,500 square kilometers, almost 3,000 square miles. That's bigger than 5 Los Angeleses and 1 New York City combined. If such a bomb exploded in the air, it would burn and kill thousands of people, damage and destroy buildings. Can you imagine the force of such a blow? To be honest, for me, it's difficult. Now it's time to launch a rocket with an antimatter bomb into space. I suggest that we explode 4.5 kilograms, or almost 10 pounds of antimatter and the same amount of matter. Why so much, you ask? I'll explain. The resulting explosion will be the equivalent in power to the eruption of the Krakatoa volcano. Almost 140 years have passed since that event. However, it's still one of the deadliest and most destructive explosions in the history of mankind. As a result of the eruption and the preceding tsunami, about 300 cities and settlements were severely damaged or destroyed. About 36,000 people were killed, and the sky around the Earth darkened for many years. While I'm telling you this, a rocket carrying an antimatter bomb has already separated its module from its payload system, and there's about to be an explosion. But something seems to have gone wrong. Sound waves don't propagate in a vacuum. Therefore, we wouldn't hear any sound. There'd be no shock wave. But an antimatter bomb exploded in space has far more serious and destructive consequences. The explosion would release intense gamma rays, and it would cause an electromagnetic pulse. This is a disturbance of the electromagnetic field. There would be enough nanoseconds for it to form around the epicenter of the explosion. Fortunately, this surge of energy wouldn't pose any danger to humans, but technology within a radius of more than 4,500 kilometers, almost 2,800 miles, would stop working. Currently, there are more than 2,500 different satellites in Earth's orbit, and even if the explosion disabled only some of the devices, our planet would descend into complete chaos. With the loss of satellites, Telecommunication cables and both underground and underwater networks would be rendered useless. Millions of people would lose the ability to use the internet, TV, and phones. The navigation satellite system would also disappear. This means that road accidents and plane crashes would probably become the norm around the world. Without GPS navigation, the transportation sector would collapse. Moreover, military powers around the world would also suffer greatly. Ground equipment, missiles, and drones would become a pile of useless metal without GPS. Without satellites, people would no longer be able to effectively monitor the weather. But the weather forecast is needed not only in case of rain. A number of countries, such as India, Pakistan, and Bangladesh, depend on such forecasting systems. Thanks to these, they know when to expect a natural disaster and prepare people for evacuation in advance. In addition, humanity would lose the ability to measure the thickness of the ozone layer, the level of carbon dioxide in the atmosphere, and the rate of glacial melting. People would essentially be forced to live and act blindly. It would take years to develop, build, and relaunch new satellites. But don't think that these consequences described are just my guesses. A mini version of this end of the world has happened before. For example, in 1962, at an altitude of 290 kilometers or 180 miles, a 300-kiloton nuclear charge in an MR-12 rocket was detonated. The operation was codenamed K3. The electromagnetic pulse was so strong that it disabled all equipment within almost 2,000 kilometers or 1,243 miles. Even an underground power cable was damaged. There were short circuits in power lines, and some wires fell to the ground. Because of this, fires started, including one at a power plant. A multi-kilometer or multi-mile telephone line stopped working. If the director of a new apocalyptic movie had been looking for a set for filming, the affected area would have been perfect. What would happen to the other planets in the solar system? I assure you, they'd be okay. As I've already mentioned, a bomb exploded in space would have no shock or sound waves. Given the vast distances separating the planets, this event would go virtually unnoticed. After all, it pales in comparison to the real explosions in the universe. For example, a comet can collide with a planet, causing an explosion of up to 6,000 gigatons of TNT. This was the amount of energy released when a comet collided with Jupiter in 1994. A bomb filled with 140 tons of antimatter could have produced an equivalent explosion. When a supernova explodes, the power is difficult to imagine. It's equal to the detonation of 550 octillion, that's 550 times 10 to the 27th power of